Welcome to this explainer designed specifically for Genesis International College students. Today, we're focusing entirely on Topic 2 of your CPCCCO2013 unit. We are going to build a really comprehensive, step-by-step guide on erecting simple formwork, basically translating all that theory right from your learner guide into practical, on-site knowledge you can actually use.
Right, let's dive straight into this critical task. Before a single drop of concrete is ever poured on a job site, the temporary mold holding it has to be absolutely perfect. It's kind of like the physical boundary that actually brings your project's blueprint to life. If this mold is flawed, out of alignment, or weak in any way, well, your final concrete structure is gonna be too. It really is that simple, and honestly, that important.
And this is exactly what you're ultimately working towards, a precisely leveled, fully braced, and waterproofed formwork structure successfully containing all that heavy, wet concrete. You want perfectly straight edge boards and diagonal braces holding everything super firm against the immense pressure of the pour. That right there is our end goal for this session. To construct that perfect mold, we're going to walk through this chronological process exactly as you would on a real job site. 1. Preparing the substrate. 2. Reviewing your formwork design. 3. Erecting and bracing simple formwork. And 4. Installing the vapor barrier.
Let's move to Phase 1, preparing the substrate. Ground zero for your concrete.
What's really fascinating here is that the quality of your finished concrete actually starts with the dirt beneath it. We call that the substrate, or sometimes the subbase. Before you even think about touching a piece of timber, you have to make sure this existing ground layer is completely cleared of debris, accurately trimmed, and heavily compacted. You are literally creating the stable, level platform that's going to support everything that comes next.
So the crucial takeaway here is this. If you skip clearing out roots or just fail to properly compact this subbase, your beautiful finished concrete structure is absolutely going to settle, crack, and eventually fail over time. The structural integrity of a heavy concrete slab relies entirely on the ground supporting it, not shifting underneath. It's a foundational rule.
With the solid foundation prepped, we move to Step 2, reviewing formwork design, the building blocks. By really understanding the distinct role of each component, you prevent costly mistakes during assembly. First up, you've got edge forms and boards. These define your perimeter and are usually chosen to match your slab's thickness, say 100 or 150 millimeters. Next are the pegs or stakes, and you'll drive these into the ground every 600 to 900 millimeters on the outside of the boards to act as anchors. Then we have the bracing, or kickers, which give you that all-important diagonal stability. Finally, the top edge of your boards actually acts as a screed guide, giving you a smooth rail to drag your tool across to level the wet concrete perfectly.
Now that we know our components, let's look at Step 3, erecting and bracing simple formwork, the assembly action.
The actual erection of the formwork always follows these three strict, straightforward steps. First, you set the line, meaning you meticulously mark your layout using string lines. Second, fix and level. You hammer in your pegs and adjust your boards to the exact finished surface level, using a spirit level or laser level to be ultra-precise. Third, secure and check. Tighten up all your fixings and do a really careful walk around. You want to make sure the boards are perfectly flush and that there are literally zero gaps at the joins where concrete could leak out.
I cannot stress this point enough, guys. Bracing is non-negotiable. Wet concrete is exceptionally heavy. We're talking around 2,400 kilograms per cubic meter, and it exerts a massive amount of outward pressure. Without proper diagonal bracing installed firmly between the form boards and the ground stakes, your structure will blow out. The boards will bow, or the entire mold will just collapse entirely, ruining the pour and costing you a tremendous amount of time and material. No way around it. Brace it right.
Okay, our formwork is built, which brings us to Step 4, installing the vapor barrier, the final seal.
That idea of a continuous waterproof layer is exactly why we must lay down this membrane beneath the slab. Usually it's made of a heavy-duty polyethylene sheeting that's about 200 microns thick. This barrier is an absolute requirement, especially for enclosed structures under the National Construction Code. It basically acts as a damp-proof membrane to stop ground moisture from wicking up into your finished floor and causing a nightmare of mold or mildew later on. To guarantee that waterproof seal, you absolutely must stick to these steps. Step 1. Preparation. Do a final sweep of your subbase to remove any sharp rocks or roots, anything that might puncture the plastic. Step 2. Carefully lay the barrier and make sure to overlap any connecting edges by at least 200 millimeters and firmly tape every single seam. Step 3. The final check. Ensure the membrane is flat, continuous, and extends neatly up the inside edges of your formwork.
You have now successfully built a flawless, protected mold. Your formwork is braced to withstand immense pressure, and your vapor barrier is perfectly sealed against the earth. So as we wrap up this explainer for topic 2, I want to leave you with this final thought to ponder. You have the perfect container ready to go, but are you ready to handle, cut, and position the heavy steel reinforcement that actually goes inside it next? Start thinking about the tools and safety gear you'll need for that, and I will see you in the next topic.